Hello, today we're going to talk about 8.4, and that is logarithmic functions. So to get started, we have 2 to the x power is equal to 4. So we're trying to find out what x is. So 2 to what power equals 4? And we all know that 2 to the second power equals 4. Therefore, our x value is equal to 2. 2 to what power gives us 8? And yes, 2 to the third power gives us 8, which means x is going to be equal to 3. 2 to the x power is equal to 6. So what power raised the second power, or 2 raised to what power gives you 6? Well, we know it's not 1, it's not 2, it's not 3. If 2 is 4, 3 is 8, we know it's going to be somewhere in between 2 and 3, but we don't know what exactly it is. So when your exponent is not an integer value, this is when we're going to use our logarithmic function. So that's the whole purpose behind logs. That's when we use logs. We have logarithmic and exponential form, and you have to know how to go in between these two forms. So if I'm going from logarithmic to exponential, I look to see how these two are related. I've got log base b times y is equal to x. Over here, exponential form, I've got b raised to the x is equal to y. So I take my b, my base, I raise it to the x, I get y. So if I'm going from log to exponential, I take the log base of 2 and I raise that to whatever it's equal to the 5th power, and that gives me my number 32. And you can check this in your calculator. 2 to the 5th does equal 32. So again, if I'm going from log to exponential, I take that base of 5, I raise it to what it's equal to of 0, and that's equal to 1. And that's true. Anything raised to the 0 power gives us 1. So my base is 10. 10 to the first power gives me 10. And yes, again, that's true. If I'm going from exponential form to logarithmic, I think this one's a little bit more difficult, but just model it over here. Your number base here is the base in the log. So here I've got the base log of 10. It's set equal to whatever your exponent is. So this number over here is a -1, which means this is 0.10, or just 0.1, since we just have 0.1 there. Here our base is 1/2, so it's log base 1/2. It's set equal to whatever your exponent is, so that's equal to a -1 again, and your answer is there. Our base is 3. We're raising it to the 5th power, so that's what we set it equal to, and this is 243. So know how to go from logarithmic to exponential and from exponential to logarithmic. There are a couple special values. If you have a logarithm of 1, you know it's going to equal 0, because any number that base can be 10, -10, 300, anything raised to the 0 power is how you get that value of 1. Another special log, if you have a log base of b. Since I have b down there, if those numbers are both b, this is going to be 1, because any number, let's say I took 5 to the first power, is still going to give me 5. So anytime I have it set equal to 1, I'm just taking that base to the first power, so it's still going to be that base. Alright, so we want to evaluate these without a calculator. So what I'm going to do is I'm going to transform them from logarithmic form to exponential form, because that's the easiest way to see your answer. So I'm trying to find out what this equals, which means I went 5 to what power gives me 125. And then you can see it's more obvious that our x value here is 3. Here, 8 to what power gives us 1, and that's one of our special ones. X is going to be equal to 0, because anything to the 0 power gives us 1. Here, 1/3 raised to what power gives us 1/3. Well, we know if it's the same piece, then that must be a 1. Our x is equal to 1. So the log base of 1/3 times 1/3 is 1. 4 to what power gives us 1/2? And this one is a bit trickier. First thing I'm going to look at is the relationship. I know that I have a relationship between 4 and 2. and 4 1/2. I know that this is half of it. I also know that if I take that and flip it to the bottom, so I'm going to have negative exponents. And that exponent is going to be a negative 1/2. Because if I had 4 to the negative 1/2, that means I would move it to the bottom to get 4 over, or 1 over 4 to the 1/2. 1/2 is really the square root, and the square root of 4 is 2. So in this case, this is equal to a negative 1/2. Next, we're going to look at what each of the bases are. If you are just given log, then your base right here is 10. Even though it's not written, it's assumed to be 10. So anytime the number is not given, we assume 10. We assume a base of 10. And this is a special base. This is our common log. Here, our base is this number down here, so we have a base of 2. And for the last one, we've got a base of e. And this is another special one. If you have a base of e, we're going to rewrite this as ln. So you should know that the log base of e is the same thing as ln, and this is our natural log. All right. So we're going to start evaluating this with a calculator. So let's go back to our calculator. And let's look to see where these buttons are. Pay attention at the top. It says you can only enter in bases of 10 and bases of e. So that second example we had, log base 2, right now we would not be able to plug that into our calculator. So if I went natural log ln of 5, I look all the way down the left-hand side of my screen, and there's my natural log button. I just enter 5, and we get about 1.609. If I want log of 10, remember we assume that's a base of 10, which is what our calculator gives us. Again, we look at second, follow it all the way back down, and we have our log of 8, hit enter, and we get that to be about 0.903. Alright, back to inverses. Last chapter we talked about how to find inverses of functions, and when we talked earlier today, we talked about going from logarithmic to exponential functions. And the logarithmic function is actually the inverse of the exponential function. So that means that when I find the composites of each of them, they should equal a positive x. So I'm going to start with my g of x, log base b of x, and if I'm plugging f into there, I take out the x and I plug in the f of x, which is b to the x power. Now we know that this has to equal a positive x. In order for it to be inverse, that's what has to happen. So therefore, this is going to cancel out. So anytime you see log base of b with b there, that cancels out and gives you 1. So we go to the next one, we want to find f of g of x. So I start with my f of x function, which is b to the x power. But I'm going to take out that x, and I'm going to plug in the g of x, which is log base b to the x. And once again, we know that this has to equal a positive x because they are inverses. I'm telling you that they're inverses, which means this has to cancel out. So here, anytime you have the base raised to the log of the same base, that's going to cancel out. So we can use this to simplify functions. When I look at this first one, I've got 10 raised to the log of 2. My base is not given. If my base is not given, I'm assuming that's 10, which means that cancels, and this is equal to 2. I've got log base of 3 times 3 to the 5th, so the log base 3 cancels, and I'm left with 5. 5 log 5, that leaves me with x. log base of 6 times 6 to the 4x. The log base 6 times 6 cancels, and I'm left with the exponent of 4x. Now the 4, the 16, they don't cancel. Always look, like the last chapter, to rewrite. I can rewrite 16 as 4 squared raised to the 3x, which gives me log base of 4 to the 6x, log base 4 times 4 cancels, and I'm left with 6x. Just like here, we assume a base of 10 since no number is given, so that's log base of 10. 100 is 10 squared, so that's 2x, so that cancels, and we're left with 2x. Alright, our last thing for our notes is actually finding the inverse function. It's just like before. The first thing we do is switch x and y. And the second thing we do is solve for y. Now when we solve for y in this case, we want to be very specific and we want to make sure that we write our answers in exponential form. Not in logarithmic, but exponential form. So if I'm starting with number 1, I switch the x and y. And if I want to solve for y, what I want to do is I want to get rid of that log base e. So given this equation, I'm going to change it from logarithmic to exponential form. So if I'm doing that switch that we talked about on the first page, this becomes your base of 8 raised to your exponent is the piece that it's set equal to, and that gives you your y. So our inverse equation is y equals 8 raised to the x power. So for number 2, we switch our x and our y. Now we talked about natural log is a special one. So that's really log base e. So if I'm taking this equation and I'm switching it from logarithmic form to exponential form, I take my base of e, and that's being raised to the x power, and that's equal to y minus 3. Now I don't have y alone yet, so I add 3 to each side, and we get y is equal to e to the x power plus 3. That may have been a little confusing in that last step there. Just remember, when I'm solving for y, all I'm doing is changing to exponential form. So I want you to go back to the very first page where we practice going from log form to exponential form, and you'll see that a to the x is equal to y. You'll see here e to the x is equal to y minus 3, and then you have one extra step to get y by itself. And that's all for 8-4.